folks, here we are at Ozone Rock Canyon, and come along, take you for a hike. So first we're going to show Rock Canyon. This was caused by a river here. You can see the valley right there. Okay, so here in Rock Canyon, it actually shows evidence of a subduction zone. We are not currently living on the subduction zone or on the plate boundary. Remember how I talked about plates earlier? But even though, so here is the subducting plate, here's the North American plate where we live on. Even though we live over here, not even close to the plate boundary, we're still affected by plate tectonics. We're still affected by this subduction zone. What's happening is that this plate is actually coming apart. It's stretching. And this is called extension. So when extension happens, so say this is just one flat plane. When this extends, then whatever's in between it will actually fall down. And we'll see a difference in elevation because it came apart. So we are looking across the valley right now. We can see mountains way over there. And then here's the valley. It's kind of hard to see. And then we turn around and we've got mountains over here too. So what do you think caused this valley? And that is caused by extension. So they used to be much closer together, but they're slowly coming apart. And that's what's caused this big Utah Valley. Now I am going to show how a subduction zone works. This is our oceanic plate, and we'll say that this is more dense than this, the continental plate. Even though for our demonstration they're both graham crackers and they are the same density. The oceanic plate is made of very dense materials, which makes it go underneath the continental plate. So let's look at this. And right now we have our three layers. Right here we have our mantle. Here we have our asthenosphere. And right on top we have our lithosphere. Now see how it just floats right on top of the asthenosphere? This lithosphere is very thick, it's very hard and brittle, and according to Alfred Wegener, this lithosphere moves on top of the asthenosphere, like floats on top, just like these graham crackers are. So here we go, they're coming together and the denser material goes underneath and is subducted underneath the continental plate and squishes down as it eventually pushed into the mantle. Okay, we're going to start again with our oceanic plate and our continental plate. And during the subduction zone, this starts and goes down underneath. And what happens is it's actually pushed into the mesosphere, and some of this material melts and comes up. Well, when it does that, then this forms mountains and actually forms volcanoes. So this gets all broken up and makes mountains and volcanoes. It's really hard to show in the demonstration, but that's what happens. Okay, so now we are going to demonstrate a divergent plate boundary. Divergent plate boundary is when two plates come apart. So first of all, they're starting here. They come apart and the magma lying underneath them is exposed. It bursts through the opening that is formed and is exposed. Now this doesn't show it very well, but you can see that if this were to have a lot of pressure like it does, once this opens up, all of the magma comes up as lava. All right, our next demo is on transform plate boundaries. A transform plate boundary is created when the sides of two plates are scraping against each other as they move in opposite directions. So this one would be going this way, this one's going this way, and they move, and this plate boundary is created by this opposing movement.